trying to combine two fractions, for lack of a better word, or maybe it's the most descriptive word, they have to have a common denominator. Now, it doesn't have to happen when you multiply and divide, but it does have to happen when you add and subtract. So we're going to look at some complicated denominators and see if we can identify the LCD. And one way to do this is with these three circles that you have drawn here. You're going to be looking for what components are the same in the two denominators and what's different about them. So if I were picking these two apart, the 20a squared b cubed and the 15ab to the fourth, the first thing I would say is, well, 15 and 20, do they have a common factor? And if I don't see it, I factor them down to primes. I say, well, this is 2 times 10, and this would be 2 times 5, and now I'm all the way down to primes. And 15 would factor into 3 times 5. And I see what they have in common is 5, okay? I'm just going to circle what's the same. What's the same is 5. That's my common factor in there so far. What they don't have the same is the 2 times 2, right? So this one has a 4 in it, and this one over here has a 3. Now that separates my number, my coefficient, my what am I trying to say? I can't think of any words this morning. That separates that leading coefficient out, and it is, separated into 4 times 5 times 3, right? And so that's sort of good. Okay, that sort of splits it out for me. Now I look at the next thing, A's. Well, this one is A squared and this one is A. And you know that if you were factoring out a GCF, you would have in common the smallest exponent. So what do they have in common? Well, they have one A in common. So what's different? Well, this one has an extra A, doesn't it? Isn't that A times A? So I can say, well, there's an A over here that I didn't put in the middle. And this one over here, well, I took that A and put it in the center. It had it in common. So I'm done with that, right? All right, let's look at the B's. B cubed, B to the fourth. Well, what do they have in common? B cubed. Now, this one over here on the right, on the left, it only had B cubed, so there's nothing extra. Over here on the right, though, there's another B that was not included. Okay, we got rid of the duplicates. What are the duplicates in them? 5AB cubed. You might note that that is like a GCF, isn't it? Didn't I factor out the greatest common factor, basically? Okay, so now how do I find the LCD, the least common denominator? Well, everything has to be multiplied together to give me the least common denominator. In other words, I have to take everything that's left over in number 1 plus the GCF plus everything that's left over in number 2 and multiply them together. The LCD is going to be equal to 4A times 5AB cubed times 3B. Now, that we can simplify that. We don't have to leave it in that format, do we? We can say 5 times 4 is 20. 20 times 3, well, that would be 60. A times A will be A squared, and B cubed times B would be B to the fourth. That is my LCD for those two really wicked-looking denominators. Make sense? Factoring out the GCF, whatever's left over, I have to kind of multiply everything together to get the least common denominator. Now, you might not realize that you're doing this, but when you do any type of least common denominator, you're doing the same thing. This just gives us a system. Now, let's take a look at this next one. It's already been factored into binomials for us. The denominator of A plus 8, A minus 5. The second denominator, A plus 8, A minus 7. What would we say they have the same? Yeah, so in the center. And when you're doing binomials like this, it's a good idea to keep them inside parentheses. Otherwise, they get we sort of decide it's two terms. When we're inside parentheses, we treat it as a single item, okay? Next, over here on the left, what do I have that's not in the center? What's different? Well, there's an A minus 5 that's been multiplied, and over here on the right, I have an A minus 7. Now, how am I going to get my least common denominator? I'm going to multiply those three things together. My least common denominator for this one is A minus 5 times A plus 8 times A minus 7. Now, it's a denominator. We don't have to multiply this out. You don't have to FOIL and then FOIL again, or multiply again. You don't have to distribute multiplication on this one. You keep it factored. because later on you might have a chance to cancel some factors, okay, when we're doing the next stage of the game. Is that one okay with everybody? Okay, we get a little more complicated when we have trinomials. These have not been factored. Now, as they are, we can't tell what they have in common because they're trinomials. But we know that everything in this life can be factored. That's all we do in this class, right? We factor. Once we learn to factor, we keep factoring. So we're going to factor this one as a binomial times a binomial. We're going to say that second operation tells us to use one of each sign. Then we're going to factor the m squared. And I'm going to come down here and say, okay, can't see what I'm doing, can you? I'm going to say, okay, I need a negative 48, negative 2. This would be m. This would be m. What factors of negative 48 would combine to give me a negative 2? Yeah, you see them already, don't you? 6 and 8. Well, which one has to be negative and which one positive? Yep, because you want a negative 2. This one's positive, that one's negative. So I got a positive 6, a negative 8. They don't have to be simplified. I simply fill them in. I FOIL to check, but it works. So I factored that one. Next, I'm going to factor the second trinomial. Same thing, one of each sign. Factor the m squared. And I can come down here and say, okay, factors, I need them to equal a negative 16. I'm sorry, I need factors of negative 16 that will give me a negative 6. If you don't need to draw this out anymore, you don't have to. Negative 16, what two factors are going to combine to give me a negative 6? It's 8 and 2. And which way do we need them? Which one's negative? Which one's positive? 8 is negative because we need a negative result when we combine them. So this one has to be positive. I know we're going fast, but by now this should be pretty quick for you. All right, now I can look at these two because I really replaced this denominator and I replaced that denominator, didn't I? So now I can look at my two denominators and I can say, what do they have in common? Did I write something wrong? Yeah, it's supposed to be 8, wasn't it? I knew that one of them was supposed to match something. Sorry, guys. Okay, so what do they have in common? They both have that one together. And this one also has m plus 6. And this one also has m plus 2. So what is my LCD for this thing? Well, I have to multiply all three of them together to get an LCD. Now, if you think your algebra is getting complicated, it is, okay? It's tedious, it's complicated, it's one step at a time, and you just have to be careful from now on, okay? Carefully thought out, go through the same system every time, get your system in your mind, and understand why you're doing things, okay? That's key. Understand why I'm doing this. I need an LCD. I have to factor everything down. Whatever they have in common, I only use it one time in my LCD, and everything that they don't have in common, well, I have to include it because everything has to be included, okay? Let's go on and see if we can start looking at what we can do with problems now. I gave you some basic rules up here for adding and subtracting rational expressions that don't have the same denominator, and you know this. First you have to find an LCD, and then you have to rewrite each fraction with that LCD. In other words, you might have to convert some of the fractions so that they have the same common denominator. Then you can add or subtract whatever's on top, and then you would keep that denominator and factor the numerator and see if you can reduce that. This last part is new to what we're doing today. Okay, you probably haven't had to do this when you've been adding and subtracting fractions or rationals before. Now take a look at this one. LCD, it's done. The LCD is 6y squared, isn't it? When you have it done like that, you can put down that denominator and you put everything else, look at everything else, includes the sign right in between them in the numerator. And then you can do the math with the numerators. That's 4 over 6y squared. And then, since everything is multiplied, you know, these are both all multiplied together, I can reduce and divide these both by 2. So what I really have is 2 over 3y squared. Let's try a little one more complicated a little bit than that. Now, this is not the same. These don't have the same denominator, do they? So I've got a denominator of y plus 1, and I've got a denominator of, x plus 1, and I've got a denominator of x minus 1. Well, this is going to get a little complicated and a little messy for me. First, I have to convert. I'm going to go ahead and put these things in parentheses so that I don't mess them up. And I have to convert those denominators so that they have a least common denominator. Well, neither one has anything in common. So to get the least common denominator, I multiply the two of them together. My LCD for this is going to be x plus 1 times x minus 1. Nothing was in common for me to put in that center circle, right? Okay, so how do I get this first fraction to have a denominator of x plus 1 and x times x minus 1? Well, let's look at it separately. I have x minus 3 over x plus 1. Now, I want it to be x plus 1 times x minus 1, so what I'll have to do is multiply it times x minus 1. But if I multiply the denominator times that, you know this, you have to multiply the numerator by it, right? Because then what we're doing is multiplying by the number 1, anything over itself, right? And we haven't changed the value of our rational, our fraction. So what happens now? Well, this one becomes x minus 1 times x minus 3 over x minus 1 times x plus 1. Now, and normally you're looking at it and say, well, I can reduce. You don't want to reduce. You just did the reverse of that so that you could get these things common. Let's look at our second fraction, x plus 1 over x minus 1. How do I get it to be my LCD of x plus 1 times x minus 1? Well, this time I'm going to have to multiply that denominator times x plus 1. So I have to multiply the numerator times the same thing. So what I have down here is going to be x plus 1 times x plus 1 over x minus 1 times x plus 1. Remember? Now let's put them back together. There was a subtraction sign in between, right? Okay, I now have a common denominator. Am I ready to start combining? Well, not yet, because I've got still multiplication of these two binomials. And in order to subtract these two binomials, the first thing I need to do is simplify my numerators, okay? Are you okay with that first? So let's come down here and say this is, let's FOIL, x times x. And then let's do outside, x times negative 3 is negative 3x. Inside, negative 1 times x is negative 1x. When I combine them, I get a negative 4x. You've been doing this for a while, so I'm expecting some of it to kind of come easy. Negative 1 times negative 3, positive 3. There's my trinomial. It's over this same. I'm not going to FOIL the denominator, okay? Because later on I may have to factor the numerators. Let's put our minus here. Let's FOIL the second one. X times x, x squared. X times 1 is 1x. 1 times x is 1x. Well, I combine those and I get a 2x. And then I say 1 times 1 is 1. Okay. Now, look at that negative in between these two fractions, okay? Well, how are we going to combine these? Sorry, I'm running out of space. So I'm coming up here. I'm going to write it all over that common denominator. I have one, so I can put everything over it, right? Whoops, plus 1. Oh, can't think and talk at the same time. Okay, so there I've got x minus 1 times x plus 1 is the denominator. And then what I've got here is x squared minus 4x plus 3. And this is minus everything in the numerator, isn't it? Minus x squared minus 2x minus 1. Don't mess that up. Okay? When you're subtracting it, you're subtracting each of those terms in the numerator that's added, okay? All right? Now let's see what we have. Well, we have an x squared here, right? And I have a negative x squared here. Well, they'll cancel. I have negative 4x, negative 2x. That would be what I combine next. And that gives me a negative 6x. And then I have a plus 3 minus 1. Well, 3 minus 1 is positive 2. What's it over? Well, my LCD, right? Still working I mean, I got it that way on purpose. Okay, now what can I do? Well, actually, there's nothing that can be done at this point. I could factor a GCF out of that numerator, right? You see the 2? I could say 2, it would turn it into 2 times a negative 3x plus 1. But does that help me? All of that would help me is if I could factor and I somehow came out with an x minus 1 or an x plus 1, so I could cancel. If it doesn't help me, I don't do it. I mean, that's as simple as it is. I'm going to leave it right there. I looked at it, it wouldn't go down any further, and that would be my answer, okay? Okay? One step at a time with this stuff. All right, let's look at the third example down here. I've got x squared minus 2x, x cubed minus 2x squared. Now, I can't really tell what the GCF is until I factor these things down, and I know I can factor an x out of this one. I'm just going to write it underneath. I'm doing a GCF here. It's really x times x minus 2. I'm going to draw a line through it. It shows I factored it, okay? That's my new denominator on this side. What's my new denominator in the second fraction? What can I factor out? What's your GCF here? X squared. Times, oh look, they do have a common factor, don't they? The common factor is x minus 2. I know I'm going to have x minus 2 as part of my LCD. But what do I have to multiply times that LCD? Well, they each have an x in common, but they don't each have 2 x's. So I have to take the larger exponent, don't I? Do you see that? Does everybody see it? When we've been getting greatest common factor, we've been saying take the smallest exponent. Now when we're getting least common denominator, we're saying, well, we have to have included the largest exponent if it's just a plain variable. So sort of the opposite there. So I have to have everything. In other words, if I just put an x there, it wouldn't take care of this x squared. But this this can be gotten to x squared, right? All right, how do I do this? This one is okay. I don't have to convert that fraction at all. But this first one does have to be converted. It is negative 6 over x times x minus 2. And I need it to be x squared times x minus 2. What am I going to multiply this fraction by? I have to multiply that one by x, so I have to multiply this one by x. So this becomes negative 6x over x squared minus 2. Now, I'm not forgetting that over here I've got another fraction. It had already been converted, hadn't it? I mean, it was already okay. So really what it's saying is minus 5. What am I doing? Sorry, guys. You know what I mean to say, right? Okay, times x minus 2, my common denominator. Better? Okay, so I've got that same denominator. And now I can put everything over that same denominator. And what do I have? Well, I have a negative 6x minus 5. I didn't have to distribute that negative far because there's only one term up there. Now look at it. Would it help us to factor anything out? Is there anything that could be factored in the numerator that could help us reduce? Anybody see anything? I could factor out a negative 1, but that wouldn't help me, would it? So I'm done. Okay? I realize that this is going to take what my old college professor used to call sinking in time. Sinking in time is nothing to be ignored. Sometimes you have to look at it, and then you have to come back and look at it again later, and then you have to come back and look at it again later. Do not neglect the process, guys, okay? I mean, sometimes it's going to take more than one time for you to see something before you actually get it. So give yourself that opportunity. If you're not getting this the first time, never fear. We're videoing. You can listen to me as many times as you want to. Okay? All right, let's go on to page 8, because this is going to get complicated today. I was working on it last night, thinking about it, and all I could think was, yeah, it's going to be really complicated, okay? So just prepare yourself for that. Maybe I'm not going to get it the first time, and then you try it again on your own, and then you come back and you listen again. All right, this is subtraction of two really complicated denominators, and I've got to figure out what's the LCD, don't I? Because I'm going to have to convert them both before I can do this subtraction. Well, I look at them and actually I can't tell what they have in common until I factor. But I do recognize this is a difference of two squares. Do you see it? So I know x squared minus 9 will factor into x plus 3, x minus 3. Remember, one of each sign, square root of the first, square root of the second. That one factored for me. I'll just kind of scratch through it here. And then I've got to factor this one over here, and I'm trying not to get everything all jumbled up here. And I've got to factor that. I'm going to try and factor it into two binomials. They would be positive signs both. X squared would be factored into x. And I need, maybe I can write it up here. I need factors of 9 that'll combine to give me 6, right? X is the numerator. And you probably see those, don't you? Isn't this a perfect square trinomial, right? If I take the plus 3 and plus 3, 3 times 3 to give me 9, 3 plus 3 to give me 6, right? Works, doesn't it? So here we are, perfect square trinomial for that one. Okay, here are my two denominators. What do they have in common? Yep, they have an x plus 3. And then this one also has an x minus 3, doesn't it? And this one has, okay, I only included one x plus 3, so this one has an extra x plus 3, doesn't it? There's my LCD. Take a second, make sure you see what we did, okay? We took the common x plus 3, I'll sort of check it off, I took that one. And then I said, okay, I have to include this because it wasn't included, and I have to include this because it wasn't included. Put little check marks by them as you include them if it helps you. Okay? I know these are duplicates, but it doesn't matter. There were two of them. So I have to use, I have to use them twice. All right, let's see if we can convert this first fraction. Now I'm going to come down here and say this is 6 over x plus 3 times x minus 3. And what do I multiply it by to get this big denominator? Well, x plus 3, x minus 3. I got to have it multiplied times another x plus 3, don't I? So I'm going to say times x plus 3 down here and x plus 3 up here. Now when I do that, I'm going to go ahead and distribute because this is getting to be a lot of steps for me. So my denominator is going to look like the big LCD. Doesn't matter what order we write them in, right? 2 times 1 is the same as 1 times 2. Multiplication is okay. We can mix it up. And then in the numerator, I'm going to say, well, that's 6 times x, isn't it? 6x. And 6 times 3. Now I'm going to do that because I know I've got to combine it with that next one. That's why I'm doing it. Let's go over here and fix this second fraction. What we had was 2 over x plus 3 times x plus 3, and I need it to become my LCD, so it's going to have to be multiplied this time times x minus 3 over x minus 3, right? So my denominator down here, same thing as I have the LCD, and the same as the first one, and I can even write it in that order so it's not confusing. And then I'm going to distribute this. I'm going to say 2 times x is 2x. 2 times a negative 3 is negative 6. Okay, what am I doing? I'm subtracting these two. Go back and see. Go back to your problem. Make sure you got the right operation in between them. If I subtract, I have to change the signs of both of them, don't I? So when I come down here for the next stage, everything is over that common denominator. And I have 6x plus 18 minus 2x plus 6. Okay? It's not as confusing when the middle operation, and it's not as tedious when the middle operation is plus, but when the middle operation is negative, you have to remember to distribute that negative. And some of you missed that on the last test. Okay, let's combine. We're going to have this common denominator, which is x plus 3 times x minus 3 times x plus 3, right? We're going to say 6x minus 2x, and we're going to get a 4x. And we're going to say 18 plus 6. So what's 18 plus 6? Anybody? 24? 86. Is it? Because right now my brain is not working and my... Thank you. Because I did it wrong on this piece of paper up here. How could I do it? Hang on, I'm going to change my notes, okay, so that I don't mess it up again. Okay. Okay, so now, what can I do? Well, I can factor out a 4, can't I? I mean, that's about all I can do, isn't it? If I factor out the 4, I would have 4 times x plus 6, right? Does that help me to reduce? Not really. So I might leave it like that just so that I can show I tried. Or you could leave it in the 4x plus 24 over your denominator. Okay? Any questions on it so far? All right, let's look at the next one. The next one says, ooh, it's complicated, isn't it? We're going to have to subtract these two and then divide by a third one. Let's deal with this one step at a time. Let's subtract these two. They don't have a common denominator. We've got to get them there, okay? Now, let's just wait about the divide by another fraction until we finish that, okay? So let's say I have an LCD. My LCD for this first part has to include both of them, right? Because they don't have anything in common. Remember, that 4 doesn't mean anything because it's added, right? I mean, if it was all multiplied, we'd say they had common, but it's not. So it's added, subtracted. You got to treat them as unique. So I'm going to take these two fractions, and I'm going to say x over x plus 4. And I want that to become x plus 4 times x minus 4, so I'll multiply it times what I did not have in this denominator. And that's going to be, well, let's just go down here. That's going to be x plus 4 times x minus 4. And what do we have? We have x times x minus 4. We could have multiplied those together, probably should have, right? But that's okay. Let's do the second one right here. It is x over x minus 4, which I will have to multiply times x plus 4 to get my common denominator. What do I have when I do that? X times x plus 4 this time. And that's over that common denominator, which I'm going to write in the same order just so that I can see it's the same easier. Now, subtraction was in between these, so I'm going to stick it back in there, okay? I got them two common denominators. I'm going to subtract them, but before I do, I need to distribute the multiplication in the numerator. So this is going to be x times x, which is going to give me x squared. This is going to be x times negative 4, which is going to give me a negative 4x. I'm going to replace that, so I'll just draw a line. Over here, I've got x times x, which is going to be x squared, and x times 4, which is going to be a positive 4x, right? But I have to distribute the negative. You get it? So when I put this down here over this common denominator of x plus 4 times x minus 4, I have x squared minus 4x, and I have minus both of those, don't I? Minus x squared minus 4x again. Okay? Don't forget the distributing of the negative, okay? Okay, so here's what we can do. This one and this one will cancel each other out. So what do you have in the numerator? Well, you have a negative 8x over the common denominator that we have of x plus 4 times x minus 4. Now, we have only done this part of our problem, the first part. We still have to divide by this fraction over here, which is the same as multiplying by the reciprocal, right? So I'm going to do that. I'm going to put it down as multiply that times 7x plus 28 over x. Everybody with me? I've got it down to where it's two complicated fractions, but it's not three fractions anymore, right? And I'm down to multiplication of two fractions. Well, that's easy, but I always cross-reduce before I multiply. And this thing might help me if I factor it. So I can change that to 7 times x plus 4, right? I'll replace it. I factored that numerator of 7x plus 28. And when I do that, I can cancel out these two x plus 4s. Can't I? All right, now I see an x here and an x here. They will also cancel out, won't they? Everything is multiplied. Remember, this is negative 8 times x times 7 times everything multiplied. Everything multiplied in the denominator and the numerator cancel at will at that point, okay? As long as it's in parentheses, right? X times, so it's really hard to cross out an x. I'll try. But those cancel, don't they? So what do I have? Well, here I have negative 8 times 7, negative 56. What's it over? Looks like x minus 4. How are we? One step at a time, right? Tedious, but expect to make some mistakes, because I make mistakes in this stuff all the time. I'll be thinking about something else, and I'll be trying to do multiplication of two binomials, and it doesn't turn out like it should. Okay, let's look at something else now. This is, to talk about complex fractions, these are complex fractions, aren't they? It's a fraction over a fraction. It's a fraction divided by a fraction. Now you could think about it like that, and you could do the math with it that way, a fraction divided by a fraction, and then turn it into multiplication of two fractions by multiplying by the reciprocal. Or look at what we have. We have a denominator of 9x in this top one, and we have a denominator of 9x in the bottom one. What if we just got those 9x's to cancel out by multiplying this fraction times another fraction that was actually 9x over 9x? Both denominators are the same, aren't they? Now look, guys, when that happens, what are you really doing? Well, I'm multiplying times 9x. I'll write it here a little closer so you can see. 9x over 1. These two cancel, don't they? And I end up with 18. This is really times 9x over 1, isn't it? I mean, it's a whole number. And these two cancel, and I end up with 9. And now I have 18 divided by 9, and that is 2. It's a different process than you have used before. But what you have to see is if I have a complex fraction, which is a fraction divided by a fraction, or a fractional numerator over a fractional denominator, and they have the same denominator, multiplying times that denominator over itself, which is the same as multiplying by 1, I can cancel those out, and I end up with a simpler fraction. I'm actually compressing my fraction down to a number over one number, or one term over another one instead of two. Okay? Yeah, okay. Let's try this one. They aren't the same at all. I mean, the numerator on this one is 2 plus 4/5. Well, I cannot add those or do anything with them until I have fixed this, can I? But what I want to do is say, okay, what's my common denominator? Well, I have a 5th here, a 5 here, and I have a 5 here. My LCD for this one is 5, isn't it? Just like my LCD here was 9x. So I found it. Now I'm going to multiply this numerator and this denominator both by 5. And I'm writing it over as a fraction, so you'll see what we're really doing is multiplying this complicated number by the number 1, which never changes anything, right? When I multiply times 5, what do I have to do? Well, I have to distribute. I have to say 5 times 2 first. Well, that's 10. And then I say 5 times 4/5. Well, they'll cancel, won't they? And this will be plus 4. There's my numerator. Let's try it with the denominator. I say 5 times 4. And then I say 5 times 2/5. Well, the 5 and the 5's cancel, because this is really 5 over 1 that I'm multiplying by, and I get plus 2. So what I have is 14 over 22. Well, I can reduce that. I can at least divide by 2, can't I? Can I divide it any further or reduce it any further? No, that looks like it. Do you see what we're doing? Find the LCD, multiply numerator and denominator by LCD. You will clear one layer of fraction. That's what you're trying to do, clear one of my layers of fractions, okay? All right, let's look at this next one. Now, this next one has an LCD that we have to find. This is a denominator of xy. This one has a denominator of y, and this has a denominator of x. What's my LCD? XY. It has to include xy, it has to include y, it has to include x. Well, xy covers it all, right? LCD is equal to xy. Multiply numerator times xy and denominator times xy. Now write it separately if you need to. When I multiply this, these two are going to cancel each other. My numerator is going to be 16x squared minus y squared. Don't worry about how complicated it is. Let's get rid of one layer of fraction, okay? When I multiply this times xy, it's a little different, isn't it? I might have to come down and write it down separately. I say 4 over y times xy is going to give me 4x, right? Okay, so that first one came out to be 4x. I say, it's going to be minus, I'll put it down so I don't forget. I say 1 over x times xy. Well, the x's cancel. And that's going to equal y. It's what we were doing on the previous page, right? I know, you're going to have to go through it more than once probably. I understand that. Okay, now what have I got? Well, I've got 16x squared minus y squared over 4x minus y. I might be able to reduce it, but the only way I'll know is if I factor it. Do you see anything special about this numerator that can factor? I mean, how would you factor the numerator here? Difference of two squares, good. So I'm going to go, one factor is plus and one's minus. I always do it the wrong way. Here, plus and minus. Square root of the first one, square root of the second one. Write down that denominator and see if now I have something in common. And I do. These match. So what do I have? 4x plus y. Okay? This is a lot today, and I'm not going to hit you with too many more examples, okay? Because I know you're going to need sinking in time on some of this stuff. Factoring, if it's shaky still, you're going to be lost until factoring is solid. Your factoring has to be solid. Are you ready? Last page, okay? I know we're not through with this test. I have another handout coming for you on Wednesday. Okay, so this one, I have actually got to look at an LCD that is 4 fractions. This one is an x, this one has an x squared, this one has an x squared, this one has an x. Somebody tell me, what is my LCD here? X squared, do you see it? X squared would take care of the x squared would take care of the x squared, it would take care of that x squared, it would take care of that x. X squared is what I have to have as a common denominator. So, what I'm going to do is multiply each of these 4 fractions, right? Because what I'm doing is multiplying times x squared over itself. So how do I do this? Well, it's up to you. Do you need to write it down separately? If so, you say 2 over x, let's do 4 fractions, times x squared over 1. Well, this cancels, and I end up with just x to the power of 1. I end up with 2x. That takes care of that first fraction. 2x plus, let's do the second fraction, 3 over x squared times x squared over 1. Well, that's just plain old 3. Let's do the third fraction. 4 over x squared times x squared over 1. And these two will reduce, and that ends up being just plain old 4. There's the fourth one, and there's a minus in between, so I write it down because I'll forget. And the fourth fraction, 9 over x times x squared over 1, right? And one of the x's canceled, and I end up with 9x. Okay, does it reduce? Well, it's a little confusing right now because it's written sort of strangely, isn't it? But these two don't have a common factor, do they? 2x and 3. You couldn't factor that, could you? What about 4 and the negative 9x? Could you factor that? Do they have anything in common? Well, if they don't, I mean, they're both not even. 4 doesn't factor out, but I see nothing. If they don't, then that is your answer. And if you could write it negative 9x plus 4, but that wouldn't really help you a lot, would it? So it's fine like it is. All right. How many fractions do I have here? Well, I've really just got two, a numerator and a denominator. But my problem here is I've got a denominator that is x plus y, isn't it? X plus y in parentheses, okay? Because it's not multiplied. So I've got to treat that as a factor. So I've got x plus y and I've got x squared. What is my LCD? It has to include both of those. They have nothing in common. So your LCD is actually going to multiply the two of them together. It's going to say x squared times x plus y. Do you see that? Okay? If you've got a denominator that is addition, group them together, okay, and treat them as one factor. So it includes both of them now. I'm going to multiply times that least common denominator, x squared times x plus y, over x squared times x plus y. And when I do that, certain things are going to reduce. I see it. I hope you see it too, but I'll write it here just in case you don't. Negative 6x over x plus y times x squared times x plus y over 1, right? I'm just splitting them out into two separate problems. When I see it like this, I can say, well, reduce, right? And then these become 1s. And what do I have here? Well, I have a negative 6 times 1, so I got a negative 6. X times x squared is x cubed. So this numerator up here became a negative 6x cubed. What about my denominator? Well, I'll write it separately just so I can see it. Y over x squared times, and I multiply it times that same common LCD, right? Putting it over 1 because I'm multiplying it separately. I can reduce the x squares. So what do I have? Well, I'm going to distribute this multiplication. I'm going to say y times x. Well, that would be xy. And y times y would be y squared. So over here in this denominator, I have xy plus y squared. Well, I don't see anything that reduces in these, but I'm going to go ahead and factor that. Now, I probably should have left good enough alone and left the GCF of y out of here, right? But once I factor it, I see nothing that will reduce. So I'm stuck. That's it. That's as far as it goes. Now, the next one is the most complicated problem, okay? But it's the same steps. It's the exact same thing that we've been doing. We have two fractions added up here, big numerator, right? It's 4 over x plus 4. I'm going to put it in parentheses. And over here, I'm going to put that in parentheses, remembering that it's addition between those two. That doesn't mean they multiplied together, does it? So I've got 4 over x plus 4 plus 16 over x plus 5. There's two of my denominators. And my third denominator is a trinomial. Well, what's the common factor? You don't know until you factor the trinomial. So let's factor the trinomial. I need factors of 20 that will combine to give me a 9, right? And you see them. What are factors of 20 that will combine to give me a 9? Plus 4 and plus 5, right? Okay, so I have factored this denominator. Now, what do I see? Well, they're the same, aren't they? As this one and this one and this one is combined. So what's my LCD here? It is x plus 4 times x plus 5. Now remember, these are two separate fractions. One of them has a denominator of x plus 4, and the other has a denominator of x plus 5. I need to get them both to the same denominator, or I'm going to multiply them both by that same denominator to clear, right? I'm going to go down here so it's clearer because this is written so small. That's your first fraction times the denominator. Because here, if you want to see it like this, what we're really doing is we're multiplying that numerator times the least common denominator. And we're multiplying the, we don't have to do it down here because we didn't have to convert it, did we? So our numerator times, hang on a minute. Yeah, we did, because we're going to reduce it. We're going to cancel it out, okay? Okay, so when I multiply this 4 times x plus 4 times x plus 5, right? What happens here? Well, it's really sort of, okay, I'm going to convert that to, it becomes 4 times x plus 5. Are we good? Hang on just a second, I want to regroup here because my notes are all wrong and I want to fix something. I think I'm back. Am I turned on? Okay, so I got that first one, that first fraction fixed. Let's do the second one. 16 over x plus 5, right? Times x plus 4 times x plus 5 over 1, right? Because I multiplied both of them by that common denominator. And what happens over here is I end up with 16 times x plus 4. Okay, so let's put it back into my fractional format here that I've got up here, because I would have cleared one set of fractions. What I'll have is 4 times x plus 5. You're not going to have anything this complicated on the test, guys, okay? Plus, and this is going to be 16 times x plus 4, right? And what is it over? Okay, well, I had to multiply both of these by the same thing, didn't I? To get them out. So what happens here is this is going to clear completely, isn't it? X plus 4 times x, I'll write it here. I've got 5x plus 21 over that denominator of x plus 4 times x plus 5, don't I? Times the same thing, x plus 4 times x plus 5 over 1. Okay, I'm just breaking it down into pieces. These cancel completely. And what you end up with is 5x plus 21. So that became my denominator. That was hard, all right? I mean, that part's hard, isn't it? So make sure you understand the steps we took. Are we good? Okay? Okay, so next, I can't simplify as it is. There's addition up here. I can't even start canceling because there's addition up here. So I'm going to go ahead and distribute multiplication. I'm going to say 4 times x is 4x. 4 times 5 is 20. I'm going to say 16 times x is 16x. And I'm going to say 16 times 4 is, what's 16 times 4? 64? 84? I thought it was 64. You sure? Yes, you're right. Absolutely. 84, right? That doesn't look like an 84, but it is. All right, down here, oh, sorry, over 5x plus 21. Okay, next, combine these. I've got a positive 4x, a positive 16x. I've got a positive 20x. I've got 20 plus 84, so it's 104, right? Did I do that right? I really wanted that to be a 64, but anyway. Okay, so can I factor anything out of this numerator? It is 64, isn't it? This is 84. That's what I had in my notes, but I took your word for it. There you go. Thank you. Okay, so now, can you factor anything out of here? What do you see that they have in common? Okay, so let's do that. I say 4 times 5x, and when you say 84 divided by 4, look at what happened, which is kind of cool, because we love it when it turns out neat, don't we? What is the answer to this problem? Yeah, well, that was so simple, right? Go back through it and do it yourself so that you don't make mistakes like I jumbled through this one today. Okay? Now listen, this requires practice. There is no easy way through it or around it. It just requires practice. Tedious practice, okay? And my lab math, I tried to pick some of its more complicated ones, although, like I said, I don't believe the next test we give you anything quite this complicated. You do need the process. So go through the process with my lab math, and make sure you understand each of these steps. Get a system in your mind and understand why you're doing it. I'm letting you go a little bit early today, but that's okay, right? You guys are good with that? All right, I'll see you next week.